Detecting and responding to threats in the cloud is harder than doing it on-prem. Even when you do have the visibility you need, legacy security workflows weren't designed for the speed and complexity of cloud environments. Cloud-native security solutions from ExtraHop are purpose-built to spot threats across the hybrid attack surface, provide detailed investigation steps, and help you automate response. Request your 30-day free trial at securityweekly.com/ExtraHop. Welcome back, everyone, to Enterprise Security Weekly. Quick announcement. Join us at InfoSec World virtually June 22nd through the 24th. Security Weekly listeners save 15% off the InfoSec World main conference or World Pass. You can visit securityweekly.com/ISW 2020. Click the register button and register with our discount code. Alyssa Miller is with us as a hacker. She has a passion for security, which she evangelizes to business leaders and industry audiences, both through her work as a cybersecurity professional and through her various public speaking engagements. Alyssa, welcome to the program.
Hey guys, thank you. It's great to be here.
It's nice to have you on the show today, talking about this issue of the software bill of materials and the dependency trees. We touched on dependency hell, which many of us have been in if you've worked, especially with Linux systems, right? And I guess I wanted to start. It was actually just this morning. I was working with some software that it hits on many of the issues that surround this particular topic of when you build software today, maybe it's inside of a Docker container and you're installing utilities and some of your own code, kind of the hidden vulnerabilities that lie in there. So Alyssa, maybe just kind of give us an introduction for our audience about some of these hidden vulnerabilities.
Yeah. So, when we look at the open source community, as it were, and a lot of these development ecosystems that people are using are really dependent on it, right? Whether you're developing in Node.js or you're in Ruby, even Java, or even to some extent .NET. Everybody ends up, no one's developing 10,000 lines of code in their applications these days. They're developing portions of that, and they're pulling in these dependencies from the open source community. And when we look at that, what we see is, you mentioned dependency hell, right?
Mm-hmm.
It's not just your dependencies. So I know I write an application and I define 6, 7, 8 other packages that it's going to include as dependencies, and it's going to pull those in. The issue is every one of those packages, of course, has their own dependencies to other open source libraries, and getting the visibility into that is what is ultimately exceptionally difficult for a lot of organizations. And it varies quite a bit based on what ecosystem you're in. But if, for instance, we look at Node.js, Node is super dependent on dependencies, right?
Mm-hmm.
That open source dependency market is so much of what goes into developing a Node application. And so when we look at it from a vulnerability perspective, what we see is, you might have maybe 5 direct dependencies, but that turns into like 74 indirect dependencies. And we see, 80 to 90% of the vulnerabilities that are going to show up in your application come from those indirect dependencies that you may not even know are a part of your application.
Right. It's amazing how one line in a Docker file can introduce so many vulnerabilities. And I don't want to knock Cloudflare, because they did a great job with this open source project I'll be talking about in depth on Thursday on Paul Security Weekly. And I was looking at their Docker file this morning, and I was like, well, this is kind of a good example, right? And it's not Cloudflare's fault, just using it as an example. I mean, there's literally tens of thousands, if not more, of these in Docker Hub that you could go examine on your own. But the first line, they're pulling Python 3.5 Alpine. And I think as developers and sysadmins, we look at that and go, well, I'm pulling a standard package, right? I mean, that's actually a pretty popular package. Like, I shouldn't have to worry about the vulnerabilities that one line brings in. But as it turns out, I mean, Sneak has done a fantastic job in highlighting the different, basically, Docker Hub repositories and the vulnerabilities just in that first line.
Yeah. Well, and that's just it, right? I mean, we look at Docker images are some of the scariest, because, like you said, people kind of assume, well, okay, it's an official image, it's the latest that I'm pulling,
right?
I should be good, right? And yet, when you look at these images and you look at we're right now writing our state of open source security report, and Docker Hub is part of what we're looking at with that. And so some of this data is fresh in my head. I go and I look at those top 10 most commonly pulled Docker images from Docker Hub, the official ones. And Node is the first one on the list. I mean, it is the most popular one. Well, you look at it and you run it through, a check to see what vulnerabilities are in there, and you find out there's, over 600, almost 700 known vulnerabilities in what is their latest official package. And I mean, you trace back into it, you find out, okay, there's a few things that are weird here, like they've, multiple revisions old version of Debian. You start digging in more, you start finding there's all these different image processing libraries, which how often in a Node server-side application do you actually really need those image processing libraries? And so, it's a challenge. And I don't think, in fact, I won't even mention the organization, but I was just reading an article that was published the other day where somebody was talking about, go grab this image. It's the official image, so you can trust it to be safe. And, of course, I'm sitting there on a stack of data that says exactly the opposite.
And I've seen this all the time. And I've kind of termed it as the internet has bad advice, right? And as a developer, when you're looking to build stuff and you read an article like you've pointed out, Alyssa, you're like, oh, this is good. I'm good to go. And as a developer, it saves you a ton of time too, right? Someone's already basically built this mini platform for you, Matt.
But even Docker tried to solve parts of this problem with Docker trusted with DTR, right? But we all know that even in those environments, those images there still have vulnerabilities because how far embedded they are down. So there is a false sense of security that even with DTR, for example, that these things, I can just grab it and use it right off the shelf. Even in those images, I still think you have a lot of challenges. Maybe not as many, but they're still there.
Well, and we have to remember, right, the vulnerability landscape in this area is very dynamic. So, Docker, DTR, they go in and they check these images and they put them up. Yeah, maybe it didn't have any vulnerabilities the day they checked it. But then you identify, new vulnerabilities, new CVs are popping up all the time. And the challenge of just maintaining and monitoring where those vulnerabilities exist. I mean, this has been the issue with open source software, and when we're talking SBOMs in particular, just being able to understand the content of your software and now your infrastructure when we get into containers. It's difficult when you have those layers and being able to monitor it and go back. I mean, I think back to like 2014 when Heartbleed showed up and everybody's scrambling to figure out, oh my gosh, do we have vulnerable versions of OpenSSL in our environment?
And this is the perfect example. Sorry, Alyssa, but it's just the perfect example to go with what you're talking about in terms of layers in OpenSSL. Because the very next line in this Docker file is APK add, and they're installing Nmap. Now, again, as a developer or a sysadmin, you may look at that and go, yeah, like that's cool. Like they're installing Nmap, and it's a stable package. Of course, Fyodor's been developing it since the beginning of time, since I can remember. But having compiled Nmap myself, I know that it includes an SSL library, right? And when you compile it, you have to define that. It includes a libxml library, and as we all know, parsing libraries can have issues with them in terms of vulnerabilities. And so knowing what's under the hood inside of Nmap, I know it's not just installing Nmap. It's installing a whole bunch of other dependencies. And the only reason I know that is because I've compiled Nmap standalone, and I know that it brings along with it all of these other things that could be vulnerable. And this is a problem not just with this package, obviously, but anything that you're adding on top of your base image now in that layer is bringing along with it a dependency tree.
Yeah, and that's the ongoing challenge, whether you're doing internal development and you're doing things like that, or like you said, you're deploying a Docker image that you pulled out of Docker Hub and made a certain assumptions, except that you actually did what I don't think a lot of developers do, and I don't think a lot of security people are plugged into, is actually digging through that Docker file and looking at, okay, what is in this image? What libs are being pulled in that could potentially have those issues? And then, like you said, you have that kind of tacit knowledge that, okay, I've done compiles on Nmap before I know what goes on here. Okay, I can predict that there's probably some of the things I need to look at. I mean, the whole point of Docker images being out on Docker Hub is to make it easier for developers. Right. And so if now you're suddenly saying, oh, yeah, but these aren't necessarily secure, and so it becomes a difficult landscape for them. And when your security folks aren't plugged in and doing their part to educate and to just be involved in that particular piece of the process, that becomes a massive challenge. And certainly, from a threat landscape perspective, it's huge. I mean, it's hard to quantify the risk picture that's involved there. And so that becomes a challenge then, as far as how do we really get the buy-in at the leadership level to maybe take more steps towards this.
Yeah, no, I completely agree. And, like you said, Alyssa, a lot of people don't even maybe take the time to look at the Docker file, especially in the beginning. And even if you do, you may look at that and go, that looks good, right? If you haven't dug in much deeper, there's so many levels here. The next two lines in the Docker file are also pretty common because Cloudflare did a great job with this, right? There were some Python scripts to automate some of this Nmap scanning to do some vulnerability assessment. And so, they copy their requirements.txt and they do a pip install. Oh my God. Now you've just brought in a whole other slew of dependencies and probably vulnerabilities somewhere in there. And I haven't actually yet looked at their requirements.txt, right? But I can imagine, that dependency tree in Python and in Node, like you've mentioned, and in PHP and all these languages and frameworks, now your attack surface just expanded exponentially. And you may not know.
Well, I mean, you just introduced a whole different ecosystem on top of everything else that was already going on there too, right? Like, I mean, all of a sudden now we've got, we're pulling things with pip. We grabbed Nmap before. I mean, this is, think about all the dependencies that are involved there. So you're in multiple open source communities now. You're not just, you've got PHP, you've got, probably Python in there and everything else. And I mean, how do you keep track of all that? And so this is where this becomes a challenge. From an operational perspective, how do you even begin to wrap your arms around this?
Right. And this is what scared me when actually Alyssa and I were talking earlier. I was like, I never really thought about it in like these three levels, right? Like I've got a base image, I'm installing packages from that distro on that base image, and I'm installing some of my own languages, frameworks, and code on top of that, right? Let alone but in my personal code, right, there's probably vulnerabilities in there too, which is again like a fourth layer, right? But in just those first three layers of base image, packages, and then languages and/or frameworks with libraries, there's a ton of vulnerabilities. I mean, Alyssa can speak to it in your report you're working on, just how many vulnerabilities can be uncovered in all the dependencies of what we just talked about.
Yeah. Well, and you look at those base images, it's actually amazing. If you even just strip down the base image, right, how much you can save yourself in terms of trouble. So, I mean, I talked about the Node one before, and okay, so that's Node latest. If I just grab the latest one, that's what it's coming to me with, almost 700 vulnerabilities. If I shrink that down to Node Slim, that drops to like 45, and none of them are high vulnerabilities anymore.
Yes. Just
by, hey, let's shrink that overall risk landscape by grabbing a package that doesn't have the entire world stuffed in it. But this has been our challenge. I mean, we can go back to servers and cabinets, right? We've always been talking about standard builds and how do we reduce permissions and reduce software that's installed to only what we need. And it's exceptionally difficult to take the time to do that. And when we think about what organizations are now doing with DevOps, DevSecOps type development, where developers are responsible for all of this, that's a lot of weight to put on their shoulders that, hey, to secure this infrastructure that you're creating, you're going to need to do all these checks. And of course, I mean, you mentioned Sneak before, I mean, that's why we're there, and why we're plugged in now. Recently, we just got plugged in with Docker, so at least you can do some of that and get developers in a point where they actually have some visibility, empowerment to start taking care of this. Because no one's going to expect a developer to sit down and go through this exercise that you're describing of walking through an entire Docker file and all the dependencies and
the other,
else.
the other defensive thing too is okay, I'm not happy with where my Python 3.5 Alpine's coming from, so I'm gonna create my own Linux distribution. Well, now we're in the realm of I'm going to create my own encryption protocol, right? Like I don't. First of all, it's a lot of work to get there, right? Number two, if I have to be mindful of my own mistakes in that process as well, in hope that I have not just me but a team of people. You're going to build your own Linux distribution. That's tricky business, right?
Totally, like you just said it. It's like rolling your own encryption, right? I mean, and what happens when someone tries to do that? So you get in there, you start building your own Linux distro. You're gonna build your own Docker image, from ground up. And what happens as a developer or even an ops person? You start to run into those scenarios that you can't solve easily.
Yes,
right?
yes.
Something's not working. I don't know why. I'm gonna just start throwing spaghetti at the wall, and whatever sticks when this thing starts to work, I'm just gonna leave it. I'm not gonna touch it because it's working. I don't want to break it again.
Yeah, it's so true.
And so that's how you end up with these bloated images that kind of go against the whole point of having containers in the first place.
Completely agree. Matt.
Yeah, true. So the last couple days, we've had some interesting conversations on this cyber/software bill of materials. So we had Jen Ellis on Monday on Business Security Weekly talking about some of the initiatives with the cyber BOM in the healthcare space. Josh Corman was on yesterday on Security and Compliance Weekly. He's been doing a lot of work with the FDA and different biomedical device stuff. And when we think about the commercial impact of the software bill of materials, I think it gets interesting, right? Because when we think about embedded systems that are leveraging these libraries, there's some challenges, I think, with embedded systems where maybe I add some additional libraries because I want those there for the future, because I might want to add some capabilities that leverage them, because I won't maybe have the opportunity to upgrade those later. But people don't understand what's in those embedded systems. And I think that's really the purpose of the software bill of materials movement, is provide visibility of what's there, where the potential vulnerabilities are. So when an attack comes that took down a good chunk of the British healthcare system, people know where those systems are. How does that work in Alyssa, I'm trying to, how does that all tie into what Snyk's been doing with the dependency trees, and how does that tie into the software bill of materials for some of these embedded systems?
Yeah, so I mean, what Snyk is doing ultimately is walking that dependency tree, and we document that bill of materials, right? Here's all of your dependencies, and whether they have vulnerabilities in them or not. Here's everything that makes up that tree. So we document that full tree, right? And that's the hardest part of so much of this, is just even understanding, okay, I've pulled in these 5 packages into my software. What does that mean in terms of actual dependencies when I start going into transient dependencies? And I mean, I think you're right. You mentioned the medical device industry, and we saw a perfect example of what's motivating that last year when the FDA came out with an alert about an open source vulnerability, and literally nobody could say what devices were impacted. And that's a scary thing. And I think that woke a lot of people up to say, all right, this is something we really need to dig into. And I know you mentioned Josh before, obviously he's done a lot of work in this space. And I know for the people that are working in this space, that was a big moment of thank you. This is what we've been talking about. So where it comes to the composition analysis that Snyk is doing, just being able to have developers freely create as they go, like you would want a developer to do, be creative, do the things that you're going to make this software wonderful, and prepare it for the future, because we know, in the medical device field in particular, updates are going to be difficult. You could apply the same thing to ICS as well. But then you're empowering them too with this capability to, okay, as you're building, so when we're integrated in the IDE, actually being able to see as you're writing this software, what vulnerabilities that's potentially introducing, at whether it's, commit time or build time, we're sitting there in the repository doing the same checks again. We're able to take a look at it from that perspective. So, okay, we've built this software. What's there? We've got our full inventory of those packages that are now in your dependency tree. And then the ongoing monitoring, like I mentioned before, how difficult it is just to be able to constantly monitor that full dependency tree when new vulnerabilities are discovered in those packages. So now providing that level of, hey, here's a warning. You have this package that's in these 3 pieces of software. It just came out with this new CVE that's pointing to some remote code execution vulnerability. That you might start looking at how to fix that. And so as it applies to the medical device field, that's really important, especially when those alerts are coming from the FDA and so forth, to just be able to go back and say, all right, yeah, we know that this Medtronic's device has that vulnerability or not.
And
Right.
How do we prioritize those vulnerabilities? I mean, Matt and I both worked extensively in vulnerability management, and it's a very contentious issue as to how you prioritize. So I don't know if there's specific things that Sneaker is doing, or your own opinions, or both, about how, when you are a developer, let's say, and you get that report back, how do you prioritize?
Yeah, I mean, so of course, some of it's the traditional stuff, right? You look at what is the potential impact of it. But if you really want to do a good job, and this is one of the things we're looking at from a Sneak perspective, is how do you analyze your use of that? Okay, so what is your threat model related to that package? If it's a vulnerability in a particular method or a particular object that you're not using, you never make a call to that method or whatever, well, that kind of lowers that overall risk and severity of that vulnerability. So maybe that's not something we need to look at right away. Whereas, of course, if it's something that is a object that you're using throughout, or it's a method that gets called numerous times, maybe it's your part of your authentication method or something. Of course, then it's going to be more critical. So yeah, when we talk AppSec, it's so much more complex because there are those caveats that can come into play there. And so being able to not just analyze now the dependency tree to know if we have these vulnerabilities in our code, but then be able to analyze to the next step and say, are we actually calling those vulnerable pieces of code to the point that they would actually be exploitable?
Right.
They're
or is the library I imported calling another library it depends on, right? Because you think I know my own code fairly well, right? And when I see a CVE come up that's, high remote code execution, I'm like, oh, it's in that method. Like, let me think back to my code. I don't call that method, right? But if I'm using a library that then has a transient dependency of another library, it's in that library code that I have to know if it calls that vulnerable function or not. And that's a much harder thing. Now I'm looking at other people's code. Good Lord. I want to gouge my eyes out.
Yeah, because now you're talking... Your static analysis well beyond your own code. You're doing static analysis
on other people's code.
These packages you pulled from the open source community. And that, like you said, that just introduces a whole new level of complexity. So without tooling to do that for you, the chances of being able to do that effectively are pretty small.
Right. And so it's really, this visibility is important, right? Because I think we established that trying to do a lot of this on your own with manual effort largely is just going to take away from your productivity in your development process, right? And what vendors such as Sneak do is give us that visibility on an ongoing basis, which, I mean, that's really what you need to be when we talk about all of these dependencies and then the transient dependencies on top of them.
Yeah, and I mean, from that visibility perspective too, it's bridging that gap, right? So you want to enable your developers to be able to do these security checks themselves, to have it be inherent to the software development pipeline. But from a security perspective and from that ops, SecOps perspective in particular, we need to be aware. We need to be validating that what is it that actually is passing through the pipeline? Are we identifying vulnerabilities? Are there things that are being introduced that we need to be aware of from an operational perspective? So yeah, giving that visibility, not just within security, not just within development, but actually bridging that all together is kind of what becomes critical, especially, again, when we're talking DevSecOps and you've got developers who are responsible for so much of this, but security still needs that oversight.
And we can't slow down development, right? because the business says go, the developers want to go. And if we're not giving it to them in an easy, consumable way, we're just going to slow them down. And then, then we're back to where we were before, where security's on the outside trying to look in.
Yeah, that's exactly it, right? So if you think in terms of like this idea of frictionless, how do you make, or another term, Netflix I know uses this, the paved road. How do you make the secure path the easiest path for the developer so they'll actually follow that one? Because if the business always wins, we know that. So if it's a question of getting product out on time or fixing that vulnerability, 99 out of 100 times the product is going to ship. And then it's also just adoption. If we as security, we need to always be striving to get adoption for the practices and initiatives that we want out there. Well, you've got to come to those people that you want to adopt it, in this case, development, with something that they can use that doesn't create new friction in their overall process.
There's another two aspects of this, I think, that go beyond in the classification of vulnerabilities, but not necessarily a bug. And one is the age of a library or some dependency you're importing, and the other is it backdoored in some way? And those are equally as important as a software bug that is a vulnerability, but a lot harder to uncover. In your research, Alyssa, have you looked at these various aspects?
Yeah, so one in particular that you mentioned there is just the idea of malicious code in what would be a trusted package. So there's a lot. We do see a lot of vulnerabilities. In fact, the number 2 reported vulnerability in 2019 was malicious packages. Yep. So these are one of two things. Either it's a malicious package that was created to be malicious, and it was put out there a lot of times, using similar names to well-known packages.
Yep. Yeah, Node had a lot of that last year.
Yes. Oh, agreed. Node is infamous for that. Mm-hmm. But the other one is there are certain vulnerabilities that could exist within a legitimate package that allow malicious attackers to introduce code,
yep.
Even without modifying that package necessarily. Of course, they could modify that package. Send a pull request, sneak in some malicious code. But the scarier one is when we talk about things like prototype pollution, for instance, where I can pollute the prototype of a particular object in a different package that's a part of that software, but it's able to modify the prototype then across the entire software or the entire application. And so within that vulnerable package now, it adjusts that object prototype as well.
I think of that as like malicious
inherency-based vulnerabilities here.
It's almost like malicious inheritance and polymorphism in object-oriented coding is the way I understand that. Is that somewhat accurate?
Yeah, I think that's a really good way to put it, to summarize it. And so, we see a lot of that. And in fact, the as far as packages that had vulnerabilities and the projects they impacted, looking at last year, a lot of the some of the most impactful vulnerabilities that were discovered were kind of centered around that. Not that they were hugely critical, but Lodash is a great example. There was a prototype pollution vulnerability in Lodash. Well, Lodash is widely popular. I think something like 4.5 million different projects in GitHub that use Lodash. And so when you find a vulnerability like that, that is pretty wide reaching. Now, it's not the most easily exploited vulnerability. So there's the impact side is reduced there, but it's just interesting to note how widespread one vulnerability in an open source package can become just based on its popularity.
Mm-hmm. Alyssa, tell us a little bit about the project you're working on now in producing this report on open source software. Were there things that surprised you?
There definitely were. I think one of the things that surprised me in particular was to see a growth in SQL injection vulnerabilities within PHP specifically. So where we see a lot of the ecosystems, it's steadily been declining to the point that many of them, it's not even notable vulnerability anymore. To see actual increase in that's a little scary. It was also very telling in terms of just the overall growth of open source across the board. I think we saw something like 110% growth in overall open source packages from last year, from 2018 to 2019. And so just to see the way that this continues to just expand beyond anything I think we could have imagined. And then, what we were talking about before with just the images in Docker, and to see that, we called out that issue with the node image last year in our report. So our 2019 report, we looked at that same image and it had the same problem. We look at it this year, new image, and the number went up. So, what that tells me is that there's really not the awareness there needs to be around that. And because people aren't demanding more secure images, and it's pretty telling that this is the single most popular image in Docker Hub, and it's got that level of vulnerability. That's something that suggests, from a security perspective, we got some work to do in terms of education and awareness.
And there's
within that space.
A lot of interesting dynamics in what you just said, Alyssa, because having been involved with open source for a long time, 20 plus years, I'm excited at the notion of open source. I'm excited when you say there's a lot more open source projects out there, right? I didn't inherit it. That is a lot more vulnerabilities, and it's discouraging to hear that some of those vulnerabilities aren't on a downward kind of swing, which could mean maybe people are not going to use open source software or not open source their software, which I think is a bad thing, right? I want to encourage people to use open source software, and to big companies, like Netflix and Uber, to release software as open source. Facebook, for example, right? I don't want to see that start to change because of the security aspect. And I think you're right. The education we have to do around this issue is quite large.
Yeah. And that's just it. And I mean, from a security perspective, my being a, former developer, but, security person at heart, that's something that to me is pretty important. It's how do we as security people do a better job of educating and making folks aware. We can't look at it as we're going to come down with some iron fist and say no more open source. That doesn't work with any of these ecosystems. I mean, unless we're going to go back and tell folks, okay, you're developing in COBOL and Fortran again.
Right.
That's just not something that's realistic. And certainly, again, from that business side, the business isn't going to tolerate it when suddenly development timelines and development costs escalate exponentially because you've said you can't use anything from GitHub anymore.
Right.
And I mean,
go ahead, Matt.
Yeah, and Docker recognized this issue a couple of years ago when I was at Layered Insight and we were having these conversations. I think it's just taking them time to start to address it. And I think the relationship with Snyk will actually start to help at least provide some of that visibility and hopefully make it better in the number of vulnerabilities that are in these base images. Because this is something we've seen for a number of years. And you're right. PHP, Node. We just see the vulnerability counts going up. That's not good in the long run.
Yeah, and that's just it, right? So I think it does actually, that partnership, I think, does a couple things. Being able to scan that image when you go to Docker and you're going to do that pull. One, it gives you that roadmap. Okay, here's all the vulnerable components that are in here. I can address these lives. I can customize this image and take these things out, or do what I got to do to eliminate those vulnerabilities. But even before that, I think what it does is it raises that awareness. Now, when I go and I pull a particular image from Docker and I can look at it and it says, okay, here's these vulnerabilities that exist in this container. Now, suddenly people are a little more aware that, all right, even though this is an official image, it can still be vulnerable. I still need to be very aware of what I'm introducing to ultimately what's going to be my operational environment. So maybe Docker Hub isn't this panacea of wonderful infrastructure that I can get for free and make my life easy.
Right.
It still is going to require some effort on my part to really evaluate and choose images that are going to be more secure and fit within my risk profile.
Or I know what Paul does is do his own multi-stage builds and creates.
Right. That's what I end up doing. It's somewhere in between, right, of creating your own Linux distro and just using whatever comes off the shelf of Docker Hub, right? But it still doesn't address all the issues. Alyssa, you're working on a report on open source software vulnerabilities. When can we expect that to be released? Rough time frame.
Yeah, so later this month, actually. June 23rd is the date that we're targeting for that. It's kind of our annual report that we do every year, and a lot of work that goes into it, but it definitely provides a lot of good insight. We're doing some new exciting things with it this year as well. Kind of analyzing vulnerabilities in a little different way than we have in the past, trying to give both that developer context as well as the security and ops context as well, because hey, DevSecOps, we need to connect those three communities and bring them together, and hopefully I think this report will do that.
That's awesome. Well, I certainly use the report as a guide when I'm building infrastructure and development environments, so I encourage everyone to check that out. Alyssa, thank you so much for appearing on Enterprise Security Weekly.
Yeah, I appreciate it. Thank you guys for having me.
And with that, we'll take a short break and come back with our next interview from the fine folks at Verica. Stay tuned.